Good morning to all. In the last class we talked about CSA for multiplication. Okay. So in the next class what I will do I will give a revision of the entire method like addition and then multiplication and division. So in today's class we will talk about the division method, and please note that we are talking about the integer division. Okay. And earlier also whatever we talk, that is the addition, not the floating point number, only the integer multiplication or integer addition. Okay. So in today's class we will started talking about integer division, and then book is Stallings. So let us take a simple example. Okay, how we do division on pen and pencil method. Okay, pen and paper method. So first we started with pen and paper. Okay. So let us divide 147 by, let us say, some number, let us say 1, okay, 0, 0, then 1, 0, 0, 1, 1. Okay. So we want to divide this number by 1, 0, 1, 1. Okay. So this number is 0, 1, 2, 3, 4, 5, 6, 7. So 128, 0, 1, 2, 3, 0, 1, 2, 3, 4, 16. So it is 144, and then 0, 1, 2, 3. So 147. So we are dividing 147 by 11. Okay. So how do you do division? So first we started from the left side. Okay. So this is something called dividend. Okay. And this is whatever we will get, we will set key quotient. Okay. Now first is 1. So this is smaller than this entire number, so this should be 0. Then they can this together, this is also smaller, this should be 0. This number 100 is also smaller than 1011, that should be 0. 1001, what is that? So this is 9, but this is 11, so this should be again 0. Now you talk about this number. Okay, so then this is going to be larger than the 1011, so therefore what we do it, we will start here, that is 1101. Okay. Now subtract 101, 110, 1, 110, 0, 0. So now you should write here 1. Next, this is what? 111 is not, so this should be down here, this should be 0. What is this value? 1, 1, 1, 1, 0. So this is what? This is, so this is larger than 1011. So therefore you should have 1 here and then 1011. Now we should subtract it here. 101, 110, so this will be 1. So this should be 0, 0. This is what? 0, 1, 2, 3. This is 14. So this is what? This is 11, 3, 14. Okay. So then what will happen? Then these will come down here. This is smaller than this value, so this should be 0 here. Then again this will come here. So now you divide it. So here this should be 1, 0, 1, 1. So this should be 1. Okay. So, now here 1 1 0 1 1 0 1. So, this will be what? This will be remainder and this should be quotient. So, now what is this number? 0 1 2 3. So, 8 plus 4 12 13. So, then 11 and 13. So, 33 11 3 43 plus 4 147. Okay. So, that is way that we do, right. So, this can be written in a flow chart, but this is one thing you remind, this is for division for unsigned number. So, maybe same thing we can write it here. Then A is 0, M is divisor and Q is dividend. Okay. And count is the number of bits. Then first what you do it, shift A Q. Okay. So, then you have to shift A Q, shift left. Okay. Then we will do it operation A equal to A minus M. Ideally, what we are doing, we are shifting left and checking whether the value is smaller than the divisor or not. If it is smaller, so you cannot do the, it should be quotient, you should put 0 and then we have to restore. Okay. So, therefore, we need to check whether this value is h less than or 0. So, it will have two parts. So, if it is not, so that means it is divisible. So, we put q0 is 1. If it is yes, then we have to restore the value. So, here it is not divisible and then we have to value restore it. So, that operation we are restoring by plus m. Okay. So, now one step is done. So, count will be decreased by count minus 1. Now, you will check count is 0 or not. If it is no, then again we have to continue this step. If it is yes, yes count is 0, then we have to end it. Okay. So, then q bit will have the quotient and A will have the remainder, that is A and Q. Okay. So, problem with this method is it is not applicable for the signed number, that means it is negative number, it will not work. So, therefore, we will have a complete algorithm for positive as well as negative number. So, that is something called 2's complement division, that will go book stalling. So, that is 2's complement first we will write the algorithm and then we will trace it with different example. Okay. So, first step is load the divisor into register M and dividend into AQ register. Okay, to register AQ, and then M will be in the divisor, or divisor will be in the M. Now, here is one Q, AQ register should have the dividend. By dividend must be represented in 2's complement. Dividend must be represented in 2's complement. And in 2n bits. So, if divisor or dividend is n bit, so it should be represented into divisor and dividend is n bit. So, it should be represented into 2n bits. Okay. So, that means A and Q have both is having n and n bits. So, 2n bits. Okay. So, one example, let us say we want to represent, let us say 0 1 1. So, this is dividend. So, this is 4 bits. So, we have to represent it into 8 bits. So, 8 bit it should be 1 2 3 4 0 and then 0 1 1 1. So, this will be A and this will be Q. Now, if it is a negative number, let us say minus 7, what will be the minus 7? So, it will be 0 0 1, right. So, this will be minus 7. So, how do you represent minus 7 in 2's complement? So, the first you write 1 0 0 1 and this should be, because this is 1, this should be 1 1 1 1. So, if it is negative number you will have here, and if it is positive number you have to represent like that. So, first task is M will be, what is the divisor, and then 2 register A and Q, that should be represented to 2's complement and 2n bits. Okay. So, what is the next step? Shift 1 bit AQ, both 1 bit left. Okay. Next step is 3. Now, we have to perform some operation. If M and, that is divisor, and A have same sign, okay, then perform subtraction, only A, otherwise addition. Now, this preceding operation is successful, previous operation, that means this one, previous operation is called successful if sign of A is the same after and before the operation. If sign of A is the same before and after the operation, before and after the operation. Okay. Then it has two cases. If the operation is successful, or A is 0, then Q is set to Q 0 position set to be 1. If the operation is not successful, and here or here and n not equal to 0, then Q 0 will be 0 and restore the previous value of A. Restore the previous value of A means before operation. Now, fifth position, repeat step to step 4. As many time as there are bits in Q, means there are untouched bit in Q. Okay. So, remainder is in A if the sign of the dividend and divisor are same, means both are positive or negative, then results will be in the quotient. Okay. So, if sign of divisor and dividend, divisor and division are same, then quotient results, quotient is in Q. Otherwise, you need to take 2's complement of the quotient Q. Otherwise, correct quotient is the 2's complement of Q. So, this is the algorithm for 2's complement division. Now, what you do it, we will check with some example. Yeah. First, we start with simple, okay, one example 1. Let us start with say let us say minus 7 3. So, what is the minus 7? 2's complement. So, this is okay. So, then what we have to do? So, we have to write key M. M is divisor. Divisor will be 0 0 1 1. Okay. And then dividend is minus 7. So, minus 7 is just now we studied, that is minus 7 is nothing but 1 0 0 1. So, therefore, first steps, load the divisor in the register M. So, that is loaded here. Next, divide in A and Q register of 1 1 1 1 A Q, right. Q will be 1 0 0 1, and then we take the counter. Count is 4 bits. Okay. So, this is initial value. Then what is next? If you go back here, first step is completed, represent the dividend must be represented 2's complement in 2n bit. Okay. Now, shift AQ in 1 bit left position. So, you shift on the left side. So, therefore, this one will come here, 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 this will be 0, this will be 0, this will be 1, this will be 0. So, this is what is called shift AQ 1 bit. What is the next step? If M and A have same sign, so after shifting, what we are checking, whether this value is smaller than the divisor or not. So, therefore, M and A, M sign is 0, A sign is 1. So, that is different sign. If it is different sign, then what you have to do? You have to add them. Okay. So, that is, if A and M have same sign, perform subtraction, otherwise addition. So, then we should add, perform A equal to, so what we do it? We perform A equal to A plus M. So, now we add it 0 0 1 1. So, then what will be the results? 1 1 0, 1 1 1, 1 1 0, 1 1 0. So, this is the results 0 0 1 0. So, we perform the subtraction. Next, we perform this step, step 2, step 3. Previous operation is successful if the sign of A is the same and before and after the operation. Okay. So, sign of A, this was 1 and this is 0. So, obviously, it is not successful, because sign is not same before and after the operation. So, previous operation is successful if the sign of A is the same and same before and after the operation. If the operation is successful, then we will do. So, it is not successful. Yeah, if the operation is not successful and A not equal to 0, and obviously A not equal to 0, then we perform Q equal to Q 0. So, therefore, it is not Q equal to Q 0. So, therefore, what we do it? We set this bit is 0. So, therefore, what we do it? 0 0 1 0, to indicate this one, we set this value 0, and we restore the value of A. Restore means this previous value should be given again. So, this should be 1 1 1 1, that is it is saying. Okay. And restore the previous value of A. Okay. So, here and counter will be decremented by 1. So, this is what we did it, operation is unsuccessful, and we restored the value, Q 0 is 0, and we restore it, restore the value of A. Next, we go back, repeat step 2 to step 4 as many time as there are bits in Q. So, again we have to go to step 2, that means again you shift left. So, this will be 1, this one will come, this will be 1, this one will come, this will be 1, this one will come, this will be 0, this 0 will come, this 1 will come, this 0 will come, shift left. So, here operation is shift AQ 1 bit. Next, go back, shift is done. If M and A have the same sign, perform the operation subtraction, otherwise you add it. So, what do we have to do it? Go back here, shift A, if A and A have the same operation, M and A have the same sign, perform subtraction M and A, M is 0, A is O, so no, not. So, therefore, again you have to add them. So, 0, 0, 1, 1 we have to add. This will be 1, 1, 1, 0, 1, 1, 0, 1, 1, 0. Again this is 0, this is 1. So, again the operation is unsuccessful. If it is unsuccessful, then what we should do? If it is unsuccessful, then Q next bit also will be 0 and then we have to restore it. Okay. So, we have to restore it and Q should be 0. So, we have to restore it, restore will be 1, 1, 1, 0, 0, 1, 0, this will be 2. So, this is Q 0 is 0, restore A. So, 2 bits is checked. So, there are other 2 bits we need to check. So, again we go back here, repeat step 2 to step 4. Again you go step 2, shift left, and if the sign is different, then you add it, otherwise subtract it. Okay. So, here shift left. So, this should be 1, this should be 1, this should come here, this 0 will come here, this 1 will come here, this 0 will come here, this 0 will come here, this 0 will add here. Okay. So, what we are doing it? Shift operation we are performing, AQ shift left, AQ 1 bit only. Next, after that, if M and A have the same sign, A has sign A, M has some sign 0, so different sign. So, what you have to do? You have to add 0, 0, 1, 1 and we add it. This should be 1, this should be 1, this should be 1, this should be 1. So, after adding, if both sign is same, then we will be the successful, right. So, previous operation is successful if the sign of A is same as and before after the operation. Okay. So, before the operation sign was 1, after the operation is sign 1, so it is successful. If it is successful, then what next? If it is successful and A equal to 0 or A equal to 0, so it is successful. Then we have to set Q 0 equal to 1. So, therefore, we should set this should be 1, okay, and we decrement it. So, here Q 0 is 1, no need to restore. Now, 3 bit is checked. So, one more bit, again we left 1, this one will come here, this one will come here, this one will come here, this 0, this 0, this 1, this will be 0. That means shift AQ 1 bit. After that, if the sign of A and M is different, then what we have to do? We have to add it. So, you add it 0 0 1 1 1 1 0 1 1 1 1 1 0 1 1 0. This sign bit is 1, this sign bit is 0. So, then it is unsuccessful. If it is unsuccessful, then what we have to do? We have to set Q0 is 0. So, Q0 is 0 and then restore the value of A. So, what is the value of A? Value of A was 1 1 1 0, okay, 0 0 1 0, and then obviously counter will be 0. Okay. So, we checked all the bits. Okay. So, then remainder is in A. So, this will be the remainder and this will be the quotient. If both are having different sign, that is we say 0 and this is 1, then you have to take 2's complement of this part. Okay. So, 2's complement of this part will be the results. So, 2's complement of this one, what will be the 2's complement? So, 1 1 0 1. So, you add it 1 1 1 0. So, this is nothing but minus 2. So, then minus 2 into positive number 3 plus this value is what? This is negative value. What is negative value? This value is, so you take 2's complement 1, you subtract 1. So, this is already 2's complement 1 1 1 0. So, you subtract 1 1 0 1 0 0 0. So, this is nothing but negative 1. So, this is minus 1. So, this is minus 7. So, dividend equal to divisor into quotient plus remainder. Similarly, you can check with some other value, let us say minus 7 minus 3. Okay. So, let us try with minus 7 minus 3. So, M is divisor. So, what is minus 3? Minus 3 is 0 0 1 1. Okay. So, 0 0 1, okay, right. So, 1 0 1 1. So, this is minus 3 and then minus 7, just now dividend is, just now we computed, right, 1 0 0 1. Then what we have to do? You have to take A, Q, count 4 and M is this one. So, dividend you have to represent. So, therefore, 1 2 3 4 1 0 0 1, right. These are the initial values. Next, after representation you have to shift left. So, shift left means it will be 1 1 1 1, these one will come here, this will be 0 0 1 0. Shift left AQ 1 bit. Okay. So, what next? We have to perform the addition. If the sign of A same, then we have to subtract. So, now you subtract here 1 1 0 1. So, 1 1 0 1 0 0. So, we subtracted. If the sign is different, then we will say is unsuccessful. That is we learned, right. If n and a have the same sign, then we perform the subtraction, that we did. If the previous operation is successful, if the sign of a is the same and before and after the operation, is it that? Before, no. So, it is 1 and 0. So, it is unsuccessful and a not equal to 0. Then what you have to do? You have to restore it and q 0 should set to 0. So, therefore, what we do it? So, we restore it, set q, this should be 3. So, we restore it, q 0 is 0. So, only one bit we touched. So, therefore, another 3 bits. So, again we shift left 1 1 1 0, this 0 will come here, 0 1 0 0. What do we do? What we did it? Shift L, shift left AQ 1 bit. Then what next? If both sign is same, this sign and this sign is same, then we have to perform subtraction. Subtraction perform is same as the addition if you take 2's complement. Okay, that we can check it. So, you perform 1 1 0 1. So, 1 0 1, then all are 0. Same as if you perform 1 1 1 0, this is what? 3, right? 0 0 1 1, 1 0 1 0 0 0. So, same thing. And now, you have to seek the sign 0 1. Oh, again it is unsuccessful. If it is unsuccessful, then you have to restore the previous value. Okay, so, what is the previous value? So, you have to restore the previous value of A. So, 1 1 1 0, and this bit should be 0, this will be 2. So, you have to restore A, q 0 is 0. Again you shift left. So, this will be 1 1, this 0 will come here, this 0 will come here, this 1 will come here, this will be 0, this will be 0, and then this will be 0. Shift left, shift left, AQ 1 bit. After that what? Shift left, then you have to check the A and M has same sign, then what you have to do? You have to subtract. Subtracting is same as taking 2's complement and add it. So, you can add it 0 0 1 1. So, you will get the value 1 1 1 1. Now, after the operation and before the operation is sign is same. If it is same, then what you do it? You put, so this should be 1 and then set q 0 is 1. So, 3. So, now it is 1. So, one more time shift left. So, this should be 1, this should be 1, this should be 1, this should go 1, 0 0, this 0, this 0, this 1, this will be 0. Shift left. So, shift left AQ 1 bit, right. Then what next? Shift left, okay, you go back. M and M have the same sign, then perform subtraction, otherwise add it. this is sign, this sign is same. So, then what you have to do? You have to subtract. Subtracting is same as to taking 2's complement, you add it. So, 0 0 1 1 you add it, 1 1 0 1 1 1 1 1 0 1 1 0. So, this sign is same. So, unsuccessful. If it is unsuccessful, so then you have to restore the previous value. So, you restore it and then put the value 0 here, put 0 here. So, restore and what next? Q 0 is 0, there is no value. So, this will be the result. So, that means 2. So, this will be positive 2 into subtraction 3 and this should be minus 1. So, this should be minus 1. So, that will give you minus 7. Similarly, you can check plus 7 minus 3. So, with that today we conclude this class, and the next class we will be talking about, we will be basically revisiting the all the circuits like adder and then multiplication circuit and then this division one. Okay. Thank you.